Friends, welcome to Neural Mind in the C++ programming series. This is episode 2. The previous episode we talked about just the beginning, what is C++, and declare a very simple, wrote a very simple C++ program. In these sessions, outcome of this session is to learn the different type of operator available in C++. Before that, just a review of the primitive data types what C++ offer. If you look at the primitive data types, so it has a plenty of options for us to use when it comes to integer numbers. Integer data type represents a whole number, and the whole number, it can be like int, short int, long int, long int, and unsigned integer. So all it varies depend on the memory storage. For example, if short int usually takes a 2 byte, or unsigned integer usually take 2 byte. Normal int data types take 4 byte. Long integer data types takes 8 bytes. So it only that space, how much the compiler or the architecture allocates to hold that value. So the range of the numbers, integer number, it very depend on that. We have to declare properly, appropriately, whenever we want to use that data types. We have float values in order to represent the fractional values. We have float, double, and long double. Character, a single character. If you want to use a single character, we can use CHAR or signed CHAR or unsigned CHAR. We have Boolean to represent true or false, where any positive value represents true, 0 represents false. When no value, we usually use it void function to represent whether the function returns any data or not. So that's what comes under data types. In these sessions, we will look into that different types of operators available in C++. So one such operator in C++ is a increment and decrement operator. So this is usually used in the for loop, a short form of increasing the variable by 1, I equal to I plus 1. Instead of using I equal to I plus 1, what we can do is I plus plus. Very simple. Look at this code here. Integer x value is 5 and x plus plus. So as I mentioned in one of my shorts video, if you use increment or decrement operator, it can be used in two ways, either as a pre-increment or as a post-increment. Pre-increment, if you do it like only single operation in a single line, there is no difference between the pre and post operation. But if you have other things to do, two things to do, for example, if you use it in a while condition where it need to check the condition as well as increase the value. Similarly, in this particular line, it has to increase the value of x as well as cout. Since it is a post increment, it gives the priority to print the value at first. So cout value, it will output 5 and then it increase the value. So when it comes to the next cout, the results will be 6. And this cout, it already from 6, it increased 1, where it will print 7. And then here we actually do minus minus. It's a post minus, so it will print the 7 and then it will minus. After print the statement, the value of variable x is 6, so it will print that as 6 here. Let's try to run the code and see what it actually happens. So here, so the first cout, it will print 5, and the second cout, it will print 6, and then 7, 7, and 6. So you have to be aware of when to use and how it differs in terms of pre and post. That is important. Next, move on to the arithmetic operator. These are the operator very often used in C++ for all the expressions. If you want to solve the expression, we will be using arithmetic operator. What are the arithmetic operators supported by C++? We have addition, subtraction, multiplication, division, and then this is a modulus operator, or we call it as a remainder operator. Let's look at a simple program. To make it simple, I have one main CPP and I have commented every time the program. Once I complete this program, I comment and then open up the next one. Let me move on to the second example here to check various arithmetic operator. These are very trivial and easy to learn. Look at that. Here I have a variable which hold the value of 10 as well as b hold the value of 3. So if we do a plus b, it's supposed to print 13. A minus b supposed to be 7. A times b equal to 30, right? And a divide b, it's supposed to be 3, right? So it will print only the whole number 3. It won't print the fractional value after division since a and b are integer data type. If you do the remainder operator, that is very important. What is the remainder operator? The remainder operator is whether the number is exactly divisible or not. If it is exactly divisible, the remainder always 0. In case here 10 and we have 3, the remainder operator will produce 1. Since 3 times 3 9, the balance is 1, right? So the remainder value after division, so it will print that value. Let's see whether this program produces the correct output or not. So we have 13, 7, 30, 3 and 1. So these are very simple. I will be passing this source code in the down under the description, the link. You can check and open that. So I can share this file and you can open it together with the online GDB. It's very simple and straightforward. So this about arithmetic operator. The most important thing you have to be aware of remainder, or we call it as a modular operator, which is a percentage symbol, right? Well, let's move on to the next code. So we have what is the other type of operator. So next we have relational operator. So what are the relational operator? Equality. If you want to check whether the two numbers are equal or not, we have to use equality operator, equal operator, which is two equal symbol. There is no space in between. You have to use two equal symbol. And we have not equal symbol like here, not as well as equal, and then we have greater than, less than, greater than or equal to, less than or equal to. So these are the relational operator we use. Mostly we use the relational operator in a condition, if condition or while condition. You want to check whether it fulfills certain conditions or not. Let's do a very simple example here. Similarly, I use the same variable x and y. X has the value of 10, whereas y has the value of 20. When we use the equality operator to check whether x and y are equal, obviously is no, right? If no, it will print 0. As I mentioned, any false, the condition is false, it will print 0. 0 represents false. Any other value represents the condition is true. Right. Now, see out x not equal to y. Of course, the condition will give the true value. Condition is true, so it gives 1. Next one, x less than y, also true. 10 less than 20 is true. You will print 1. When x greater than y, it will print 0. Let's check that as well. So there you see the output 0, 1, 1, 0. Very simple and trivial when you learn that programming language. Now let's move on to logical operator. So logical operator are used to check multiple conditions, whether the condition fulfill more than one condition, if x greater than y and or r. So what are the logical operators available? Look at that logical operator. So we have and, or and not, 3 logical operator. 2 ampersand symbol is an and operator. This is the or symbol. You can see on the right hand side above that written key, most of the keyboard. And exclamatory symbol is a not symbol. Let me go through uh, some simple example for logical operator. So look at this code. We make use of an integer variable age equal and initialized to 25, and we have boolean to represent has id equal to true. Okay, the id equal to true. We have a condition here. If age greater than 18 and has id, if that means it is true, both condition. Whenever you use and, you have to use the and table. Only true and true will give the true results. True or false, false or true, false, false, everything gives a 0, right? So that's what here. So if age is greater than 18 and is true value, allowed to enter, it will print. If either one of this condition, okay, age less than 18 or don't have id here, either one, here is must both, either one it fulfill, it will print. Let's try to run this code to check the logical operators allowed to enter. So I want to see this output. So one way is, if you reduce the age to 15, let's see what happens. Not allowed, it will execute this condition. It won't, because one of the condition is false, whereas the other condition is true, right? Age is 15 now, but has id is true. Either one is true, the result is considered false only. So it will execute this part. It won't execute the statement under this if condition. It will execute only this part, right? So let me put back to 25 and let's assign the value false to the id, has id. So when we try to run the code, now it will show not allowed, right? It will show, it will print not allowed. So this is how the logical operators works. So we have and, or not operator. If you have any question, please comment. I will answer the questions as well. Next, move on some special operator available only in C++. So those are all called bitwise operator. So what are the bitwise operator? So bitwise operator, when think of bitwise operator, it works with the binary bits, binary numbers, zeros and ones only. Even though if you pass any whole number, when the compiler apply any of this bitwise operator, it automatically convert the number into binary form, and then it apply whatever bitwise operator we are using it. Let's see one more example for that bitwise operator as well. Look at that here, and I let it comment it out. I put it comment, right? Okay. So this is a very simple program. If you look at this code, sometimes it may be intimidating, but it is very easy to understand. Look at that. I initialize a variable a as integer type and assign the value 5 to it. Similarly, I have a variable b which holds the value of 3. Right? But if you convert 5 into binary form, it will be represented with 0, 1, 0, 1, 0, which means the first number gives the value 1, all right, and the second position is considered 2, and the third position is 4, 8, 16. Likewise, it will continue. So 1 plus, there is 0 at the second place, the to position 2, and third one is represent 4, right? Plus 4 now. So it is equivalent to 5. 1 plus 4 is equivalent to 5. So similarly here, so the first position is 1 plus 2, second position is 2, third position is 4, and then 8, and then 16 from right to left. All right. Now, if we apply the bitwise operator, so what will be the output for the first cout? The first cout, we apply AND operator. AND operator means only when both having the value of 1, it will give 1. So here first position 1, 1. The rest all 0, 1, 0, 1, 0, 0, 0 all become 0. So the result will be 1 only. Here or if you consider this way 1. Okay, so that is the binary representation. Since it is integer, it will put it 1. It will print 1. Okay, look at this A or B. So either one is 1, either one is 1, it will consider true. So 1 and 1 is considered here is true. So let's see, just write it from here. 0 and 0 is 0, 1 and 0 is 1. This between 0 and 1 is 1, and 1 and 1 is 1. So 1 plus, so this becomes 1 plus 2 plus 4, which is equal to 7. Right? So you have to move from here. Move from right to left. 1, 2 plus 4, 7. So it will print 7. And this is another example of using what symbol? XOR symbol. So if you do XOR symbol, it will show you the opposite. So in a sense that it will show you 6. Okay. So you can, if you look into the XOR table, then you will actually know how this actually prints. And here is two other symbols also I use. For example, I initialize the value x equal to 4, and 4 is represented by 0, 1, 0, 0, correct? What we can do is we can easily shift the right position or to the left position. If it is binary number, if it is a binary number, right? So shifting, we have left shift as well as right shift. If it is left shift, what we have to do? We have to add the 0 at the right hand side. So if I add the 0, the 1 become the 8th position of it, because 1, 2, 4 and 8th position. That's why the value is 8. Okay. If for this example, so for where we are adding 0, the initial value of 4 can be represented in the binary form like 0, 1, 0, 0. So if we add a 0 onto the right hand side, if you add a 0 on the right hand side, now 0, 2, 4, 8, the value become 8, right? But if we add the 0 in front to the left, right? If we add to the 0, it will become 0, 0, 1, 0, 0, right? If you put that. So here, if we shift it to the right, it will become 4. So this is actually, all right, it will give the, no, this one is become like that. Already have 0, we are adding one more, 0, 0, 1, 0, yeah, okay. This one become like that if you look into that. So 0, 1, 2, 4, 8. Here is 2, 1 and 2. So these results become 2 only. So let's see whether it gives that similar number. So we have 1 at here. When you do A and B, bitwise operator 5 and 3, you will get 1. If you do OR, bitwise operator A or B, you will get 7. A XOR B, you will get 6. And here, if you use the left shift, you will get 8. If you the right shift, so the 1 is moved to one position, right? So it will become 2 here. So this is what all about the operator. So we have, as a summary, so what we have, what we learned so far, as a summary, what we have learned so far, we learn different types of operators. Before that, we talk about the primitive data type. Primitive data types is that there are many different ways to use the data type, depend on the usage. If we optimize, if you want to optimize the code, we may use appropriate data type. But to learn, just to learn, we can declare the variable is not significant if you declare integer instead of short int. If you declare unsigned integer or long int instead of unsigned int, so it doesn't matter. But some specification or if you are writing an embedded system code for electronics or embedded system, we have to be specific since we don't want to make waste the resources or a memory, correct? So we learn about increment decrement operator. This operator can plus plus is the increment operator, minus minus is the decrement operator. It can be used as a pre-increment or pre-decrement. Same way, it can be used as a post-increment or post-decrement, right? And we have arithmetic operator very often used to do arithmetical operations. We have relational operator to compare inside the if condition or while loop, and we have logical operator for more than one condition. If you want to check, we will be using logical operator. So you should be aware of how the AND, OR, and NOT works. It's a logical operation. And we have bitwise operator. If it is a bitwise operator, it works among the binary digits or bits. Okay, so we have AND, OR, XOR, NOT, it has a NOT, as well as left shift and right shift. It looks like the insertion and extraction operator, right? But it works differently. So that is one of the concepts, the polymorphism. We talk about that later on when we move on to objects and classes, right? So, friend, so that's all about this episode. If you like this video, please like, share, and subscribe so that I will get a motivation to do more. And I will be sharing this code, so practice this code as well. And we see you in the next video. Take care.